Today we're going to be looking at Checkov, and the purpose of Checkov is basically for IAC scan. And since we're treating Terraform series, I believe it is important for us to look at this tool and to see how it can help us to scan our Terraform code as well as our Terraform plan. Now, if you look at my screen here, this is the page for Checkov. One of the things we're going to be doing in this video is to show us how you can actually install Checkov on an Ubuntu machine and use it to scan your Terraform configuration locally. One of the importance of that is when you're done writing your Terraform configuration as a DevOps or DevSecOps engineer or cloud engineer, whatever your role is, you actually want to scan your Terraform code even before you commit it into the Git repository and submit a merge request. Now, in most organizations, I understand that you have a CI/CD pipeline. You push your code into the Git repository, you submit a merge request, the pipeline is triggered, the merge request does all the checks, does all the scans, and then of course your team lead or whoever it is that is responsible will review whatever scan, whatever results that the scan has produced, and then of course make the decision whether to merge or to revert back to you and say, you know what, you have to check this again and make these adjustments and correction and all of that. But then sometimes when you are able to do this locally before you even push into your repo, it saves a lot of time and it saves you a lot of iteration, right? So that's one of the reasons why we're going to be looking at how to do this locally. And I believe it's very important, all right, for us. Now, two things we're going to be looking at. We're going to be looking at scanning your code, and we're also going to be looking at scanning your plan file. Now, normally, before you run your Terraform apply, you usually will do a Terraform plan. And in most cases, you can actually save the plan to a file, right? And then you can apply whatever you've saved into that file to ensure consistency and all of that. But then sometimes when you scan your code, there might be some changes that have occurred between the code you scanned and the plan file that you generated. So it is also important that you scan the plan file just to catch whatever it is that may have be included that the code scan did not, capture. And that is exactly what we want to do. So first of all, we're going to go to AWS. We're going to set up an EC2 instance to, install Checkov and to start ISC scan. And of course, we're going to be using a little bit of some examples that are not too technical, just to give us an idea of what Checkov is able to do. And of course, we're going to be looking at some Checkov options, flags, and all of that. And of course, Checkov is it's open source. You can actually use it within your pipeline. You can use it locally, and you can also, define your own custom, rules as well. But we're going to be using the already available rules. That's the one we're going to be using. But as an organization, you can develop your own rules in YAML. You can develop your own rules in Python, and of course, define your own policies and all of that. So I'm going to call these Checkov. Of course, we're going to be using Ubuntu. And of course, we have the Ubuntu 26.04 LTS version here. That's exactly the one we're going to be using. Right here also, we're going to be leaving this to T3 micro, all right, for the purpose of what we want to do. I'm not going to be using the keeper, okay? And of course, I'm going to be leaving my VPC that way, and I'm going to select a security group. And since I'm not using a keypad, there has to be a way by which I would access my instance, right? So I'm going to select an instance profile. So the instance profile basically has the SSM manage instance scope policy. So that way my instance is registered with session manager and I can access my instance securely from the browser, or even or locally if I want to. All right. And of course, I'm going to be using spot instances, all right, just to save on cost, right? Since we're not doing something very critical, just to show us an example. So, I mean, I don't want to go with on-demand instance, so let's just go with a spot instance right here. And we can go ahead and launch, all right, the instance. Now, on this instance, when the instance boots up, there are a few things we're going to be installing on the instance. We're going to be installing Terraform, we're going to install Checkov, and we're going to be installing the AWS CLI as well on the instance. So I'm going to wait for this instance, the status check, to return 303 to tell us that it is ready. But of course, you can always click here and click on connect. And we can see here that the status check has not passed just yet. And of course, these are different ways that you can connect, right? EC2 instance connect, but that will require SSH keys, which we do not have. There's the instance connect endpoint, but of course, session manager, it tells us here that this is maximum security. And of course, this is IAM authentication, and that's why we're going all right with that. So we have to wait here for this status check to pass. But of course, we can see that the instance itself has been registered with session manager. And of course, we can see the ping status here showing online, and it is also showing connected. And that's the purpose of the IAM role that we associated with the instance. And that's what the policy does. The session, all right, manage instance call. It basically registers your instance with session manager. Okay, so let's connect. I don't think we can wait for that forever. So let's just connect to the instance. And of course, the instance seems ready. So here I can just do a sudo su right here. I'm gonna go to cd, and here I would want to bootstrap my instance. Well, not bootstrap really, but I mean just install a few things that we need. So I'm just gonna call the script.sh, and I'm going to paste a few configurations that I've put together here. We're going to copy them right here. So I'm going to paste this. So if you look at what we have, this is basically, all right, a shell script that would install Checkov. So this is the installation for Checkov. All right. And then, of course, we have a CLI installed, we have Terraform installed, we have Checkov, we have AWS CLI, we have Terraform, and these are all the things that we want to install. So I'm going to save this and exit out. All right. And right here, of course, you can do your chmod, chmod plus X, all right, and all that. But if you don't want to do chmod plus X, you can basically just say bash, all right, script.sh, and you still get the same result at the end of the day. So this will go ahead and do all of the installation, perform the updates, do the upgrade that is necessary, and install all of the tools that we have specified in that script, right? So let's allow this to run. So like I mentioned, we're going to be doing, all right, the code scan, we're going to be doing the plant scan as well. And I think it is important that you actually run this locally before you push, all right, your code to the company's repository, because it saves you a lot of time. It saves you a lot of iteration, right? So whatever it is that a pipeline will catch, you've already been able to catch, that issue locally, and you'll be able to resolve it, except for the ones that maybe there is nothing you really can do about it and all of that, but it saves you a lot of time. Okay, so instead of waiting for the pipeline to report back and then you start making the corrections and everything, you already, all right, have made the necessary corrections and adjustments, and then whatever it is that you push into the Git repo, you are sure that at least it doesn't contain any kind of vulnerability or any way by which it can be exploited. Okay, so that's the importance of doing this. So now all of the tools have been installed. So one of the things that we must note about Checkov is that you have to activate the virtual environment, right, before you can actually use the Checkov. So here I'm going to say source dot, all right, venv slash bin slash activate. Okay, so now that is activated, if I do a Checkov right here, of course, it should show me the Checkov logo and all of that, right? So it's showing us the Checkov logo and also showing us the version that we have. So now I would create another file. So it's going to be nano. So let's just call this AWS o1.tf, right? And I'm basically going to copy a little configuration, all right, into this. So I'm going to come here, and of course, we're going to paste this. We're going to paste this here. So this is a simple AWS configuration, but there's some anomaly here, which is access key and secret key, which is not supposed to be. All right. So, but of course, we're doing this for the purpose of testing, right? Now, when you want to use Checkov to scan that code that you have, okay, -F, and you point it to the file, all right, -F01.tf, and then you press the enter key. So Checkov is going to scan that file and it's going to report to us the vulnerability that it has found. So here it's telling us that, okay, these are the things I found. So there are some that passed and there are some that failed. For example, this one passed, it says, resource instance should not have public IP. Yes, the instance does not have a public IP. Ensure hard-coded secret does not exist, all right, in the user data. We don't even have a user data script, so there's no hard-coded data, all right, anyway. And some other things here actually, all right, failed. Now, one of the things I need to point out here is if you look at this link basically would normally redirect you to a guided, all right, page where you can see how to fix some of these reported issues. But then when I check this, I think these pages are no longer, all right, publicly available, or maybe they've archived, these pages. I wouldn't know. But when I checked, it didn't take me to the place where you would see the guide and, of course, how you can make the necessary corrections and how you can do all of that. So this is where it just lands, right? It's not going to show you anything other than this. Okay. Well, basically, if you look at what you have, there's a description as to what the issue is. Okay. So, for example, this one, it says ensure instance metadata service version 1 is not enabled. All right. So that tells us, okay, this is why this check actually failed and it didn't pass. Here it says you should ensure detailed monitoring for the EC2 instance. So if you look at all of the information we have at least enough information to know why the check actually, all right, failed. Now, one of the things you can also do is that you can actually use this, is a label now or tag that I will call it to either, narrow down whatever it is you want Checkov to scan or not scan. Right? What do I mean? So, for example, if I'm only interested in detecting if there is any access key or secret or something within my Terraform code and all, I can basically come here and do Checkov, all right, -F, right? And of course, I can also point it to the file, which is this 01. Okay, and here I can basically say -fin check, all right, and so I can come right here and copy this, or even copy it up to the point where you have secrets, and then you can paste this here, and of course put an asterisk. So which means What I'm saying is that what I want to check is anything that has the tag CKV secret, right? And so if I press enter, what this will do is that it's going to exclude, all right, other scan or other label or other tag, whatever name you want to call it, and it's basically just going to narrow it down to that particular tag that I have selected. So if you look at what I have here now, I mean, it basically just gives me the report for CKV secret 2, and that's it. So the other ones, I mean, those ones have been excluded and all that. Now, another thing here that you can actually also skip a check. For example, if you, let's say, for example, you have this, EBS optimized, right? Let's say that's what you have. Okay, or let's say ensure all data stored in launch configuration or elastic blocks store is securely encrypted. So let's say, for example, that this, whatever it is you're doing with this instance you want to create, let's say you are just testing out something. Maybe it's in a sandbox environment, or maybe a test environment, and some of these things are not really required. All right, you can actually skip, some of these things, and of course, you can skip them, using, a comma. Okay, so for example, I can bring up that one again and say, you know what? I want to skip certain things. So I'm going to say hyphen skip, all right, to check. And I can put that label there. So basically, I want to skip this. I can put a comma, all right, and say that also want to skip, all right, this one. So let's basically just take this too. Okay, so I'm going to put this here as well. All right. And so I'm skipping CKV AWS 8 and CKV AWS 135, right? Those are the two tags that I want to skip. So if I press enter, now it is going to give me, okay, so let's see. It's telling us that there's an error. Okay, so let's take a look at why this gave us, all right, an error. Unrecognized argument. Okay. If you do a Checkov help and you scroll all the way up, all right, so this is the flag right here, skip check, and it says checks to skip, all right, any other check will not be run, and either one or more items separated by commas, and that's exactly what we did. So each item may either be this or this check ID or a severity. If you have severity, blah, blah, blah. And it says this option can be combined with check. With this priority is given to explicitly listed this and that. For example, if you use skip check this and check I, all right. So basically it tells us that we can actually have one or more items separated by commas. So I don't know why that, the one we did, I don't know why it failed. So let's take a look at it again. So we have the skip check. Okay, and I believe that is correct. Okay, all right. So basically, let's try one and let's see what it gives us. Oh, okay, maybe there's not supposed to be a space or something. Okay, maybe we're not supposed to put a space there. So let me do CKV underscore AWS underscore 135. Okay. Maybe we're not supposed to put a space. So let's take a look at what this gives us. Oh, all right. So we're not supposed to put a space between the commas, right? It was just supposed to be comma and then the next one. Okay. All right. So if you look at what we have now, you would see that we can't find the CKV8 because we're skipping 8 and 135, right? So if you look at what we have here, we have 88, 46, 79, 126, 41. All right, we have 41. All right, as well. And then, of course, we have 2. So those 2 have actually been skipped. So that is, what that does, all right, for us. So you can skip, you can check, and you can do all of that. So now, this is basically us scanning the code. Now, let's talk about scanning the plan file. Okay. Now, of course, I mean, you can't have a plan file until you have done Terraform init and then you do a Terraform plan. So let's take a look at what that will take, okay, for us to do. So basically, I'm going to copy another configuration again, All right, and we're going to look at that together. So let's clear the screen here. So I'm going to call this nano aws02.tf, and I'm going to drop that configuration right here. So here we have these, just a demo. All right, so this is basically a demo. So we have the CIDR port opened up. This is IPv4. All right, from port 22. And normally this is bad practice anyway. So you're not supposed to open up your SH port, all right, to everybody, particularly it's an ingress rule. So which means anybody can SSH into your instance. So that's a very, very, all right, bad practice, all right? So of course, if we do Checkov -f AWS, all right, -02.tf, it's going to also read the code and, of course, let us know that there's a lot of errors here. Of course, a lot of things passed. So 8 of them passed, 4 failed, all right, as well. So here, ensure security group has a description. So we didn't give it a description. Ensure no ingress groups allows 000 to port 22. Okay, so that's a security issue. Every security group rule has a description. So these are some of the things that we can actually, all right, fix. Okay. But now here is the problem that I want us to look at. So if I go here now, for example, if I do a nano and I open up that file, okay, and I, all right, just do a little bit of edit. So if I come here to this CIDR IPv4, and I come here and I basically just say var, all right, IPv4, right? And I do this, okay? Now, if I run my Checkov again, let's look at what, you can see that it actually passed. Can you see that? Ensure no security groups allow ingress 00 from port 22. It says passed because I have replaced that value with a variable. But take note, that variable does not have a value just yet, right? But at the code scanning level, Checkov says, oh, I didn't see 0000, so it means that, it's compliant. Okay? Meanwhile, there's no value for it yet. So which means at the point of doing Terraform plan, right, the person who is creating the infrastructure can actually enter 000 and the person will do apply. And maybe if it gets to the CIC, that's where to be, the error will be cached and everything, right? But even when it gets to the CI/CD pipeline during your merge request, right, depending on how you set your, code scanning in your CI/CD and everything, it basically can just scan and look at the variable and say, oh, okay, everything is fine. There's no 00 here and everything. Because in your CI/CD pipeline, if you're not doing plan scanning, if you only stop at the level of code scanning and you're not doing plan scanning, then these kind of things are easy to miss. You first of all have to do a Terraform, all right, in it. So let me look at it. I think I have two Terraform scripts here. So let me remove the first one so that it doesn't, or let me just create a folder, mkdir, all right, AWS02, and I can move the AWS-02.tf, all right, to AWS02, okay? So I can do that move. So I can cd into AWS02, all right. And of course, you can do your Terraform init right here. But that will require some credentials. So let's see that. So I'm using an AWS EC2 instance and also it has an IAM role associated. So Terraform initialized successfully. So now if I do a Terraform plan, right? Okay, so normally that variable is supposed to ask, it's supposed to ask that I supply the value for that variable. So let's see what we have. Okay, so it's telling us here that reference to undeclared input variable, all right, on this. Now, this the reason why we got this error and it didn't ask for any value, right, is because we didn't create that variable. So if you look at what we have, all right, we only just, use that variable there to deceive Checkov, right? But the variable was not actually created. So if I go back here now, all right, the only thing we have here is just var IPv4. So there are two ways you can go about this. You can assign the value, all right, when you're running your Terraform plan, during the CLI, or you can come here and then do variable, right, IPv4. So let's look at the first one. So the first one is you can do a Terraform plan like this, all right, and then you do -var equals, all right, the name of the variable is IPv4, right? So you can do IPv4, okay, equals, so let's say 0.0.0. Okay, so remember to, okay, yeah, I think we're doing it correctly. All right, so you can do it like this, and then you do your Terraform. So let's see what that will give us, because the name of the variable is a variable name that was assigned on the command line, but the root module does not declare a variable of that name. Okay, add a variable block to the configuration. So it's asking us to add a variable block to the configuration. Okay, var IPv4. I'm trying to look at what we have again. Nano AWS EC2. All right, so here I'm going to declare that in the file. So we're going to say variable. Okay, so let's just say this is variable IPv4. Okay, and that's it. So now if we try that option again, this one, I think we should be successful this time around. All right, so there you go. Now look at what you have. So eventually the 00, all right, came back into it. Okay, and this is at the plan stage. Let's see how we can use Checkov to scan the plan itself to catch things like this. So now, normally when you do your Terraform plan, you usually would save your plan to a file, right? And in some environment, you take that plan file and within your CI/CD or something, you send it to, maybe to a Slack channel or something for a review, all right, before that configuration is eventually applied. So here we can do Terraform out. Okay, you can do -out and then give your Terraform plan a name. It can be tfplan.plan or whatever it is you want to call it. Okay, and of course you can press enter, right? So once you press that enter, okay, so it's asking us to supply the value. So you can 000/0, and of course that would generate a plan file for us. Now, the plan file that will be generated most times is not readable. So if you look at what you have here, it says you have your plan saved to tfplan.plan. So now, if I do ls, I will find that tfplan in my current working directory. Okay, but if I do a cat tfplan.plan, it's not readable. All right, I can't read this. So here, what we can do here is there's what you call the JavaScript query, all right, processor, and we're going to be using that as well because we can actually convert that plan file to a JSON, all right, file that is readable. So what you can do is you can do a Terraform show, all right, and then of course JSON, and you do your tfplan.plan, and you pipe that to JQ. Right. So if you pipe that to JQ, it basically would, interpret that plan file in, all right, JSON language. Okay. All right. So you can see what it has done. Right. This is JSON. So this is readable, right? Compared to the raw Terraform plan file. So what we want to do is that we want to take that raw plan file, convert it to JSON, and then now use Checkov to scan, all right, that JSON, okay, file. And so that's what we want to do. So I'm going to bring this up again, JQ, and instead of printing it out on the console, I'm basically just going to say this is tfplan, all right, .json. So save that into a JSON file. Great. So now if I do ls, so I have the raw plan file, and I also have the JSON file that, we just saved. So now even if I do cat tfplan.json, right, you can see now that it's readable, right, compared to the raw one. So now I can come here now and do Checkov -f tfplan, all right, .json. So that is scanning the plan file. Okay, and so if I scan the plan file, then Checkov will be able to catch, that particular error and say, hey, there's a problem here. Now look at what it did. So again, it says ensure no security group allow ingress 00 to port 22. It's still telling us that, that passed and everything. That's fine. But right here, it says ensure, all right, now this is CKV AWS 24, right? So at this point, it was able to catch that error, saying ensure no security group allows ingress from this to port 22. So it was able to catch that in the plan, all right, file, okay, in the plan file. So that is how to scan your plan file. So even if at the code level, some things were missing and all, by the time you generate your Terraform plan and you subject it to a scan, you will be able to catch, all right, errors like this. So I want to believe that we've learned another thing again today. I want to believe that this has been an insightful session. So don't forget to like, subscribe, and share. And of course, I'll see you on the next one. Bye for now.